Hello people, welcome back. And in today's session, we will be understanding the kurtosis of the data. Kurtosis is basically talks about the peakness of the data. So there are three types of kurtosis. First we call as an leptokurtic. When the peak is little high, peak is sharp than expected. Then we call as an mesokurtic. When the peak is as expected, which is basically normally distributed. And then we call as an platykurtic. Platykurtic of the data when the peak is shallow or less than expected. So how these leptokurtic, mesokurtic or platykurtic data look like? Suppose if I make a data and the peak of the data is too sharp. Basically data is representing a thin widerness, or the width of the data is less and the peak is sharp, then such data is called as an leptokurtic data. If I pick up a data set which is perfectly balanced, which means neither the peak is high or nor the peak is low, then this is called as a mesokurtic data or the normally distributed data. And if the peak of the data is too low, then such kind of data, which is the peak is more wide, data is more wider and the peak is low, then such kind of data is called as a platykurtic data. So statistically, if you want to say kurtosis, we want to check. So the kurtosis of the data is expected between 0 plus or minus 3. If kurtosis of the data is between 0 plus or minus 3, then this data will be your mesokurtic data. If the kurtosis value of the data is greater than 3, then this kind of data will be too high peak or sharp peak will be leptokurtic data. And if the kurtosis value is less than minus 3, because 0 plus or minus 3 is mesokurtic. If the kurtosis value of the data is less than minus 3, then this kind of data will be platykurtic data. So we calculate the kurtosis of the data and we look what is the value is coming. If the less than, it is within plus or minus 3, 0 plus or minus 3, then it's a perfectly balanced data, mesokurtic data. If the value of the kurtosis is greater than 3, then it's a leptokurtic data. And if the value of the kurtosis is less than minus 3, then it's a platykurtic data. So let's take an example and just generate some random number. Random data, maybe this data is your production and we wanted to see my production is too high or too low or it's a normal production. And suppose production you are producing, suppose around 75 pieces per hour to maybe 90 pieces per hour. And I'm just generating some random number for last 3 shifts, which means all 24 data points I have. So this is the hourly production of last 24 hours. And here I am pasting as a value. Now, if I want to see kurtosis in Excel, I just simply use a formula for the kurtosis. So this data kurtosis will be is equal to KURT. And here I go. And if I see these values selected in the formula, KURT formula, my value is minus 1.44 as per this data. So minus 1.44 is very well between 0 plus or minus 3, but still it is not exactly 0. It is on the negative side. So peak is little less than expected, but still it is within the expected range. Expected value will be, it should be 0. Though 0 plus or minus 3 is accepted. But if it is on the lower side, which means it's moving towards the leptokurtic, maybe this is a symptom. Then you need to see your process that why data is showing a low peak and variation is high and the mean value is little less than expected. So what will be doing this? We need to investigate. Though it is not significant, but we really do not know if we ignore the symptom when this problem will turn out to be a special cause. So this is the way we calculate the kurtosis. Thank you so much, people, and I'll see you in the next session.